now we are going to talk about negative reinforcement, and particularly we're going to talk about avoidance learning. And I'm just going to give you a reminder of why this is particularly interesting. Recall we spent several sessions talking about positive reinforcement, different ways in which positive reinforcement may be scheduled, and we spent a little bit of time talking about punishment and what makes punishment effective. But in both cases, positive reinforcement, positive punishment, what we're ultimately talking about is how the presentation of a stimulus, a change in the environment, may result in a change in behavior. That is somewhat intuitive at the end, that if you do something and something happens as a consequence of that, then your behavior changes. It may increase if the consequence is appetitive. It may be reduced if the consequence is aversive. Now, on the second column, when we're talking about the removal of a stimulus happening as an effect of behavior, we talked about omission training and DRO, and we talked about a particular a particular stimulus being present, and then disappearing or going away because of some behavior that that was emitted, and because that stimulus is appetitive, then the behavior will be reduced. You would not want to engage in the behavior that makes something that you like go away, but that one thing that you like, that reinforcer, may it's going away, and it's going away has is a change in the environment, and so your behavior is having an impact, again, a salient impact in the environment. We can even see that also when we're talking about escape behavior, because if you're experiencing food shock and you can do something to make that food shock go away, or you're watching a bad movie and you can do something to stop watching that movie, then you're changing the environment as a consequence of your behavior. But when we're talking about avoidance learning, now we're talking about something different, because in avoidance learning, your behavior is preventing a change in the environment, is preventing that an aversive stimulus will be presented. And so what maintains avoidance behavior is the absence of a change. That is very counterintuitive. Think again of the shuttle box experiment that I described a couple of video lectures before. The animal moves. In the case of escape, the animal shuttles or moves from one side of the chamber to the other, because that movement, that locomotion, cancels food shock, removes the food shock from the experience of the animal, right? That is not surprising at all. What's surprising is that if you give a warning to the animal that food shock is about to happen, the animal learns to engage in behavior that prevents that food shock from happening. And it's the fact that food shock is prevented, that is, that nothing changes, because the world is exactly the way it was before before the warning actually happened. Before the warning happened, there was no food shock. If you avoid the food shock when the warning is presented, then the world remains the same, and that maintains behavior. So what maintains behavior in avoidance learning appears to be the absence of a change in the environment. and that is very counterintuitive. That has been a matter of investigation and of debate, many investigators, and there are at least two different accounts for what actually happens in avoidance learning. The most classical traditional explanation is called the let's put it here, two process theory. So let's think about what happens here. Remember your ABC: antecedent, behavior, consequence, right? So what happens in according to two process theory is that in an avoidance situation you have something like this is the light that tells the animal that food shock is about to happen unless shuttling behavior, moving from one side of the chamber to the other, takes place. If that takes place, there's no food shock. But during training, two processes may be taking place. One is Pavlovian conditioning, the pairing of light and food shock. By virtue of this pairing of light and food shock, light comes to elicit a fear response. This is Pavlovian conditioning. And the shuttling behavior may serve to escape from fear or reduce fear. So, and it's effective because shuttling actually cancels the food shock. So in the context of shuttling, there is no fear response because no food shock is being presented. So ultimately, what happens is that the animal first learns process number one, Pavlovian conditioning. Light is paired with food shock, and this light comes to elicit fear. That is process number one. And process number two is that in the context of fear, shuttling reduces fear. And thus and so the animal escapes from fear by shuttling. This is operant conditioning. This is escape behavior. This is negative reinforcement. Now escape, we can understand escape because it means changing something in the environment as a consequence of the behavior. Now the environment, the aspect of the environment that changes with escape is kind of like an internal environment in a way, because it's escaping from a particular emotional state, and this state of fear. So what the two process theory does is it reduces avoidance learning to escape behavior, escape learning, right? Here's an alternative explanation though. Let me keep, well actually I need to erase just this, and we'll invoke another other theory oftentimes goes by the uh, called predation, uh, predation imminence theory, and it's as the name suggests, um, it um, it assumes that a lot of avoidance learning comes from the evolutionary the selection pressure to avoid predation, and the way that this explains avoidance learning is that indeed there's a Pavlovian conditioning process um, going on in which light is paired with foot shock, and that light comes to elicit a fear response. Well, actually, but this fear response is um, what this fear response is an anticipation of an aversive stimulus, and it's an adaptive response to um, an aversive stimulus. So this fear response may be expressed in different ways. So, for instance, think about the foot shock as if it was a predator. What would you do if there is no way to escape the foot shock? You're gonna get it no matter what. Well, then you freeze. That's an adaptive response to a predator. As if you cannot escape the predator, might as well stay quiet and maybe the predator won't notice you. But what if there is a way to escape it? If there is a way out of getting out of the foot shock, well, then uh, that fear response, put it in quotation marks, it's expressed as locomotion, as running. Notice that this is what's involved in the shuttling behavior. It's just running. This is the response that is elicited by um, this fear state, by this association between light and foot shock. The animal is not shuttling to escape a fear state. The fear state elicits the shuttling behavior when there's the possibility of moving somewhere else. This is sort of like one process theory, in which all of this is just Pavlovian conditioning. But what the two process theory and the predation imminence theory predict, though, is that as this behavior becomes more and more effective, so as training happens and the shuttling behavior happens more often, the animal should experience less foot shock and the light may be less effective at eliciting fear, and therefore reducing the amount of shuttling, which results in more foot shock, and so on and so forth. It is unclear whether that happens, whether this cycle happens of light being paired with foot shock, eliciting shuttling, which cancels foot shock, which reduces the effectiveness of the light in eliciting fear, which reduces the shuttling, which increases the foot shock. All this cycle. It's unclear whether this actually takes place. It seems like the light is actually very effective at eliciting this fear response, even in the absence of the foot shock, once it has been established for some time. So this predation imminence theory has other implications, like for instance, um, what happens when, what is the response to food shock itself, to predation itself. What you would expect will happen is some kind of defensive response, a startle or a jump response. This is what happens when an animal is actually being attacked. And if you think of it, the light, what the light is doing is serving as a warning, telling the animal that it's just about to be predated, that it's just about to be attacked. It's not being attacked, but it's going to be attacked. And therefore, it elicits, in by itself, elicits this locomotor behavior if that's an adaptive response, or freezing if that's an adaptive response. A and very uh, clear demonstration of this predation imminence theory is that supports this theory is the fact that if you use a different behavior, different than shuttling, let's say lever pressing, to avoid food shock, it is really difficult to get avoidance learning through lever pressing. The animals do not lever press to avoid food shock. They will shuttle to a different place to avoid food shock, but will not lever press. Why not? Well, the two process theory would not have an explanation, but the predation imminence theory would explain that shuttling is a natural response, is the most appropriate response to an anticipated attack. Lever pressing is not. It's not built into, in this case, into rats, to engage in manipulative behavior as in anticipation of an attack. What they engage in escape behavior as naturally as in anticipation of an attack. All right, this pretty much concludes our discussion of punishment, escape, and avoidance.